Yeah. So talking about installation first. Okay. So as far as installation is concerned, please install Anaconda, TensorFlow, Keras. Okay, make sure TensorFlow and Keras are inside Anaconda. Okay, that's all. Pip install TensorFlow, pip install Keras. Okay, so
what will be the platform? Is it Windows or Ubuntu?
The local machine stuff I'll be doing in Windows.
Okay.
But most of the cloud operations, I'll be using AWS. Okay, and if you want to, I mean, what I do is for extensive training, I quickly use it, get done. You might use whatever you choose, but okay, so AWS. Okay, I have a little high-end machine reserve, so cannot keep it always using. Okay. Hi, folks online. Is my screen visible? Yes, Ganga. Change the audio settings. Yeah, it's correct one. So, okay. So what? Okay, so we'll see that later. But here, like EC2 instance, if you see, I have this instance. P2 XP2 is for GPU based systems. P2 X large. Okay, I use it. This is Ubuntu based system. Okay, if you want to create if you do launch instance, okay, then here they will do an option. Yeah. Deep learning AMU. So this has, if you do this, it has already Anaconda, everything installed in it, TensorFlow and all the stuff's installed here. So you can do select. Okay, then instance GPU compute. Okay, if you do, you have this guy and this guy. Because it is too expensive, use this guy for 1 gigabit. Okay.
Where is it?
Huh? This P2X large, right? Okay. This is quite per day. You will get a couple of hundred rupees. Okay, easily. So more than that, I think 700 or so if you run it all the way.
What's the cost of the first one?
First one is okay, manageable. I don't remember exactly. Like if you run for 1 month, a couple of thousands,
okay,
5,000-7,000 sort of thing. I mean, Spain from that's around my bill, 5,000, 7,000. Okay, so do that when I'll tell you the process. It's not that you put deploy, copy, or start writing code there. You don't do that. You don't want to pay the price for writing code, right? You will write code in your normal machine. Then everything with subset of the code, then we'll put it there and deploy it. Okay, then do trainings there. Okay, you will use sample subset of the data to train the model and see the sanity is okay. Then you do extensive training in those GPUs, right? So we'll see how to do that. We'll learn how to do that. But basically, this is what you'll do. This is the machine. Okay, so assuming that in your local machine you have Anaconda and TensorFlow and Keras installed. Okay, let's get started. So create a directory which has name it something that suits your interest. and we'll learn to use Spider also here, so that if you are running, not everything needs interactive interfaces. Okay, so deep learning anyway, you can't see a lot of things. So when you are written all the code and basic sanity is done, you can ship the stuff to Spider. Okay, so that it actually, if you talk about CPU of local Windows machine, right? This is browser based, so it stacks. Okay, and entire application browser stacks, a lot of other applications. So you better use Spider for this. These are like cheap tricks which can continue make your working experience smooth. Okay, so Spider. So initially we won't be needing that. We won't be doing so much optimization, but as towards 30% of the course, we'll be getting there. So let's start. So the first thing that we'll do is I'll try to introduce TensorFlow. Okay. So this is like introduction to TensorFlow, first few things, then I'm going into neural networks. Okay, the first chapter is mostly getting comfortable with TensorFlow. Okay. Now, import TensorFlow as TF, then you do TF dot __ version shift enter. It will tell you the TensorFlow version that you are into. This is similar to other guys also, TensorFlow. Okay, now this is the first sanity. Then you just check import Keras to check if Keras and everything is fine. And you can see here, Kera, what is TensorFlow now and what is Keras now? TensorFlow is a low level, number. It's very similar to NumPy. Okay, NumPy is what? NumPy is a mathematical computation library. The limitation of NumPy is it can do everything that is there in one machine only. Okay, it is not capable for doing distributed, matrix multiplication in a matrix which is distributedly stored, right? So whereas TensorFlow is capable of doing that. Okay, TensorFlow is capable. So it's not that you might be hearing that TensorFlow is the most popular deep learning library. There are some myths. It's not that it is solution to every problem. It's definitely popular because Google is pushing it a lot, and there are a lot of people who love Google. Okay, but there are other libraries as well. So if you learn the philosophy of deep learning, eventually you should not be dependent on the library. There is something known as PyTorch, which is good. I've used it. It is good at. Okay, PyTorch. Okay, so these are other libraries which you can use eventually. So so this is the TensorFlow that you're importing, TF.
See, just now you mentioned about PyTorch, right? At a very high level in a layman's language for me to understand. Like, can you just tell what is TensorFlow and PyTorch?
Yeah, of course. So these are different libraries, like different code bases altogether. Okay, who is managing, who is creating, who's writing code for TensorFlow? Google folks, Google brain team. Who's writing code for PyTorch? Another community. Right? It's basically different, people who are trying to solve the same problem. That's it. Okay, there is something known as Cafe 2 also, which is also another deep learning library. Okay, so depending on what are your roots to it, you may choose whatever you want. Like Opencv is another such library. Opencv is for computer vision related task.
Okay, exactly. What is computer vision? It's just image processing.
Image processing. Image processing is a vast area. We'll see here. It involves object detection. It involves segmentation. It involves localization. Okay, there are a lot of things. Like in an image, how many objects are there?
What is localization?
Localization means bounding box. In an image, so I think yesterday only on some class I was doing it. See this? Can you see this? This is localization. These are like a photo. We identified that this is giraffe, this is zebra, this is zebra, this is zebra. Understood, right? This is your bounding boxes. This is segmentation. You can see that picture, the kind of boundary it is separating it out. Okay, we'll do this. This is image. This is part of image.
This is not k-means segmentation or so.
No. It is deep learning segmentation means finding the finer boundary of the image and where the image, where the particular thing is. Like if you are, this is the thing that get used in self-driven cars. You have to understand what is the, you understood when the frame car is there, where is the car?
As far as I understand segmentation is nothing but grouping of similar variables with similar characteristics.
It is clustering.
The clustering is nothing but segmentation.
I mean, you can say it, but when you talk about in images segment, this is not a semantic segmentation. Okay, if you talk about in image, what is segmentation? Say segmentation can have, it's a generic word. It can have infinite meanings depending on the context, right? But if you talk in this world, it is about finding the it's precisely which object does this pixel belong to, this information. This pixel belongs to zebra 1. This pixel belongs to zebra 2. Okay, very close to that. A lot of things we will learn in the process.
One thing, one doubt, just now you told that when I say segmentation, it means finding the boundaries. See, one example like which I saw on the Google, there is something called TensorFlow for poets and all. The documents you give an image and you identify whether it's a tulip or a rose or like that. So even there also we are talking about segmentation.
Give an image, you'll identify?
No, like there is a something called as TensorFlow for poets, right? When we from the Google site we can download that data model which contains all the high definition images of the class actually. So if you run that program, say image underscore label, when you say give some JPG, it will tell what is it jasmine or a flower, a rose or tulip, it will tell. So I just wanted to put
that is classification.
Classification. Okay.
I'll come to that. Okay. I mean, it's a little early to we'll deviate or inform course to finish. Okay. I understand. I mean, there is a lot of interest part there. We'll just be with the flow. Okay. So those are the things we'll discuss in can CNN, and later we have a specific chapter for image processing. We'll be discussing about a lot of things. All this will be discussed.
Yeah. One more thing. If I would like to try on AWS, you have some documentation I can go choose like this and this.
Nothing as such. I can. The name is just P28X large. P2X large.
So you mentioned something like EC2 and all. That's what I was getting confused. Like.
Just launch instance. Okay. Somehow get there. Okay. Launch instance and search for deep learning. Deep learning AMI.
Deep learning AMI.
It has everything pre-installed in it. CUDA. The thing is, if you try to use GPU of your machine and do that, in case you have one, you have to install CUDA. These are like libraries which will use your GPUs for deep learning. Okay, there you don't have to do anything. It's all pre-installed, and it is a difficult task. I mean, installing all this stuff is a difficult task. Okay, so let's come back here. So let's understand one by one. Okay, what is TensorFlow? So you understand the environment. What is the scope of the course? Basically, in a nutshell, I'll tell you. First, we'll understand TensorFlow, nitty-gritties around it, basically how to write low-level code. We'll write low-level code of linear regression, logistic regression. Okay, low-level, very low-level code. Like, do that. We'll do the matrix multiplication by ourselves. All these things we'll do. After that, we'll be getting into neural networks. We'll see a lot of mathematical concepts behind it. See, neural networks is definitely more than just layers, as we understand. Okay, it has a lot of whys in it. Okay, I earlier I mean, I still avoid doing that, but now I've started talking a little bit about whys in neural networks. Why is what is back propagation, and how does the maths really work? Might be a little complex. If you get it, it's great. If you don't get it in first attempt, that's okay. I mean, numbers are not so high. People get it first. I mean, it doesn't. Anyway, after some time, you can come back and understand. So that's fine. Then talking about CNN, RNN, mathematically what they are, then layer wise what is happening, how this information flows. Then we'll be getting into little more details of object identification, text processing tools. One chapter focused on object identification, object processing, image processing, that talks about object identification, classification, segmentation, right? Another topic which talks about text processing, what sort of pre-processing is required. Then we'll discuss about autoencoders and GAN for feature selection part that will be used. Okay, then how to use pre-trained model. This is a very important topic, and this gives what I see, this gives learners a high. In the sense, suppose like, I'll give you one example. So we have a data set which consists of different type of dogs and what are their breeds. Okay, so now you can use pre-trained model and actually strip off few layers from the end and train the model for dogs breed only. Okay, and all of a sudden you see, this is a model which is started working now for dogs, which will identify dog breed, and with 95% accuracy. It is good actually. Okay, similarly, there's some examples I'll quote. There is a company here which from the clothes they will identify what is a category: male, female, collar, with collar, formal, informal, by just photograph. I'll tell you how their deep learning model will work and what is the 30 lines of code that was written to solve their problem. Okay. So after finishing all the stuffs, we will be getting into hyperparameter tuning. Just some research paper will discuss where they tell it how to find the best model parameters, why the structure of models is this way. Okay, some developing that intuition. That's where we go. Okay, this is the whole story in a nutshell. The current course will undergo some changes. Okay, because I think this sums it up pretty well. This too. That's the whole agenda. Okay, let's take one by one. And in text processing part, we'll be discussing a little bit about how does chatbots these days get deployed. That is in the text processing. Okay, so let's first start with TensorFlow. So what we did now, we just imported TensorFlow. So how is this TensorFlow processing really different? Huh? Okay, so if you see, what is Tensor, I mean, generally tensor is not a term that is coming because of TensorFlow. Tensor was some point 30 years back, maybe more. Okay. So what is a tensor basically? Tensor is a smallest data point to hold data. Okay, data processing. For example, you see here, this is an operation here, add. What is the data that you are passing here? 1 and 2. What is the output? It is doing an output of 3. So this is a tensor, you can see. You have the data, you have the processing. Okay, this together is called tensor. So what is TensorFlow? Internally built is TensorFlow is internally built by connection of all these things. Okay, it looks like this. It looks like this. Understood, right? Each of the element is there. This is the input data. Whatever data is here, right? It is getting from here. It is passing to multiplication. So what is the vertices? Vertices are operation. Edges are the data. Got it, right? Vertices are the operation. Edges are the data. Yeah. And you combine all these things as much as possible. This is what does it form like? It forms like data flow graphs, isn't it? So what are we trying to do using TensorFlow? We are trying to do numerical computation using data flow graphs. That's all the idea. Okay, whatever computation you want to do, like you want to do a plus, you want to represent ax plus b. How do you represent here? It would be simply as, ax, suppose this is a and whatever x is coming here. Okay, a and this x is coming from outside. Actually, this is similar to the x. So this is doing ax, this is the result here. This is multiplication. This is a is coming. No, sorry, I spoke something else. So this is your data that is coming a, and suppose you have a okay. So ax, and suppose you are just assume this guy is not there. Okay, then a and whatever is the value coming from here x, it can do the multiplication and it can add with this data ax plus b. So the essence is we can plot this data when you're doing this operation. Whatever mathematical operation you have, it can convert that into graph data flow and implement it. That is what TensorFlow does. Okay, whatever operation you want to do, it can, whatever code you write, generally in machine learning cycle, what you have seen, you write each line gets executed when you start executing, right? Here, when you write the code, it doesn't execute. It does something known as delayed execution. There is there is a new feature from TensorFlow which talks about eager execution. Okay, so that is little different, but essentially what it does is, whenever you write the code, it will not execute. Okay, the first phase is creating the graph phase, then running the graph. Understood, right? First is creating the graph, then running the graph. So the two-stage execution. Okay, so when you are writing row-level TensorFlow code, we will first create the graph, then we will run the graph. Okay, so for example, we have to implement linear regression. In linear regression, what do? You have what do you predict? You predict the value of coefficients, isn't it? A and ax plus b. If you say a and b, you want to predict. Okay, of course, and so you how will you do in this case will give us a lot of insight. How does this really work? Let me just touch upon how to create variable, how to create TensorFlow variable, how to multiply, how to do this operation. Then I'll move to that. Then it will actually clear the concept what is happening. Let's take one by one. tf dot constants. Okay, can you see this? If I create a, this is what I'm creating a constant. Constant means the value will be pretty much fixed. But if I'm trying to print the value page, it shows does nothing, right? Huh? That's because what we did here, we just created an edge here. I mean, we just created a constant here, and we didn't execute it. Only after execution it will show the values and all. It didn't execute the graph. Okay, similarly, we just create one more thing. Basically, this is a hello world program. Okay. Generally, what happens if I do h plus w, it shows the result, right? Here nothing, because you didn't execute it as of now. Okay, so first, then what you have to do? We want to create a graph, create a connect. We want to create a graph, then want to execute it. These are two different things. H and W, two different things. We want to have an add function here, which will take H and W and return the result. Basically, concatenation in this case, right? So H plus W is there. Okay. Result. As we have seen earlier, nothing is here. Now we want to execute it with tf dot session. So what is it happening? So inside this, with tf session means you are creating a TensorFlow session. Session means whatever it is like graph in execution. A session can only execute a TensorFlow graph. We have created a graph, but when inside this session, how do we access this session variable? Ses. Inside this, tf.session is represented as ses, right? That is what with code means, right? So if you do ses dot run result, got it, right? Now it executes.
But B is coming.
Huh? B is your encoding technique here. Okay, this is U, B, all this encoding. The string is this hello.
TF doesn't session has instantiated the.
It has executed the graph, has instantiated the graph. Yes. Fine, right? So it is like graph in creation and graph in execution. You can do other things also here, but generally, you should not be. This is the part where you need to see the graph also. Is it real? Okay, so what you do here is giving a name to that, so that when plotting it, right? And remember, when you are working in a notebook, you should reset the session. Otherwise, your screen will completely be hung. Your graphs that will be created, right? Multiple graphs will be created. So you should actually reset the graph here, so that it doesn't confuse us. Reset. Default graph. Okay, I have to always do this. We are giving a name here.
Evolution is open.
Okay, you're giving a name here. And when you're executing it, right, I want to see the graph basically. Okay, that is, you should do that from the beginning itself. So as to understand what is happening. Here dot sorry. Here dot summary. File writer. Tensor board logs. Right, it will actually write the file, write the graph that is created and all. It will show the graph here. I think the tensor board directory was not present here. That's precisely because I didn't execute this line. Okay, execute from here. Okay. If you execute in the middle of it, I mean that was the dependency check. Because the idea is REST is dependent on H and W. If H and W is initialized again, you need to reset the stuff. So that is what it is happening. So let's see the graph now. Okay, so what you would have done is inside deep learning, this has created this TensorFlow. This has created these logs. This is the file that it has created. Okay, so you can see the graph. You need a PowerShell there. Okay, it will pop up that allow access. Once you allow access, you can see port 6006. We're adding this guy. Okay, so you have to see this HW add. This is the graph that got generated here. Okay, if you click here, you'll get all the properties. The input is H and W, both of them are scalar. This is understood. This is a very small example actually. And just imagine what happens this too when you have complex neural networks. Right? So H, if you click on H, you'll get what is this H. This is string, okay, and the type of it. All this information you will get operation constant. Right? Okay, so you have a hell lot of things here. Okay, a few of the things still does not work as expected, but Few of them are silent releases, like releases happen, features happen, but they're less vocal about it. Okay, so understood, right, how to use it, and just keep a check when you're using it. The host give local host, otherwise it becomes inaccessible.
We are getting some error, right? Where a TensorFlow binary was not compiled to use AVX2.
That is basically GPUs.
Okay.
This system do not have GPU.
Okay.
So if you run this on a GPU based system, you will not get this.
So if you run the same program on AWS,
no,
will not come up.
Okay, that's what actually. Though I haven't debugged it, what is the actual root cause of it, but this is what is the observation.
Okay. But once you make this, one command prompt and execute from there.
Execute the graph to see the graph in charts. Okay. So this is a basic thing. Let's proceed further. Okay, so we understand what is graphs. Now it was a very simple graph, right? Only two, three things. Graphs, sessions, pitches.
See, one doubt, see, whenever we write a TensorFlow program as a standard practice, every time we need to write this reset default graph.
Not really. Okay. Depend. Actually, what does this thing do? Right? If I don't write this, if I execute this code 2, 3, 4 times, right, in the graphs that you're seeing here, right, it will show 2, 3, 4 graphs independently getting created.
Okay.
Okay. I mean, different graphs.
Why?
Because it doesn't understand the scope. It will keep creating. There is nothing which tells it to delete it. Okay. Though you're executing same code, how does that guy know you're executing same code? Right. So reset default graph keeps the thing clean. Okay, and this is more useful when you're doing notebook, because in notebook you in the same process is same, right? You're just executing it again and again. Had you restart the process, then it is okay. In Spider and all that, you restart that entire process. That's okay. Here you don't do that. You execute, and be careful when you are changing middle of the code here. Okay, remember that if you execute some part, it might generate a new graph. So as long as you are doing independent things, better to use this reset default graph. Otherwise, it will keep on adding graphs and it might lead to confusion. That's the whole idea. Even if you're not doing it, you know it that this thing might happen. That is also enough.
And this is most specific to Jupyter mode.
They're most specific to Jupyter. Okay. Now let's create a graph and A equal to TF constant right equal to TF. Now what do we want? By default, right, as we have seen earlier, by default, everything goes to default graph. Right? If you don't mention here anything and you do this, EF dot add A command. If you do this, this becomes part of default graph.
What do you mean by default?
Default graph means even if you're not creating a graph here, okay, this code, this thing is part of a default graph. Okay, these are like if I do this one more time. Okay, you have these two things. If you see the default graph here, these all will be part of it. How do you know that? EF dot get default graph is here, right? You can see the address here. Huh? Then draw graph. Do you see the address and both of them are same, right? Yes. Right. So what does it mean? All these are part of default graph. Okay, default graph means what? You know, if you think from the aspect, TensorFlow is meant to parallelize things. Okay, I will keep feeding this information. TensorFlow is meant to parallelize things. Why was GPU? Okay, now that we understood okay, TensorFlow, I was expecting one question by now. That is precisely why do you need it? Why do you need something like TensorFlow here? Why was current scikit-learn not enough? Oh, we understand deep learning. This question actually comes when we understand deep learning. So, precisely in your scikit-learn, it is not able to, scikit-learn is a machine, foundation machine learning library. You cannot parallelize linear regression. Not every algorithm can parallelize because when you talk about training the models, right? Not everything can be charged. Not everything can be executed in parallel. Understood, right? Not everything can be in parallel. Like linear regression, you cannot use half the training data to create half the you cannot mean them up. This does not work always. Okay, this is not work. It will not work with all the algorithms. What is that is the incapability of the algorithm, and as well as the information that can be shared. Okay, now what happens here? It can very well divide the task so that it can be executed by different GPUs. Okay, they can talk with each other and it can bring you faster results. Okay, that is precisely because of, if you can break down your complex task into a graph model like this, you can, and this graph model works on dependency, right? We will execute in session.run R, but what will it execute? It will execute all the previous dependencies of R, isn't it? R is dependent on A and B. Just imagine A being dependent on X and D. It will execute them also. So it resolves all dependency things. Okay, your TensorFlow does all dependency management by itself. Like, for example, this is if I write here, see, if I write here R, if I do this, right? What does it mean? S is dependent on R, right? Yeah. If I execute session.run, I haven't executed anything here, right? If I execute session.run S, it will execute R also. You don't have to call separately for R. Understood, right? So, and you can you can offload the responsibility of execution till R in a parallel GPU. Right, that will happen parallel. You will do the rest of the computation, then you will combine. Right, this graph sort of framework, this data flow graph that's why very well suited for distributed execution. That is why we can do it. Okay, that is why we can do it. So if you ask me what is the benefit of using a linear regression TensorFlow, I can say that if you have a distributed version of linear regression, you can make things parallel. Right? Like, let's see here. Now you have what you have. Both of them belong to the same default graph. But what do you want? You won't say this guy to be part of another graph. So what will you do? We'll do this. First, create a new graph which is not default graph. G is equal to EF.
Just to understand, first you have to add it. Then here the dot default graph. What this code 94 is doing is there. What is the function? What is
this one? Yeah. This one is returning you the default graph's address.
Okay.
Okay. Then you do r dot graph. It is returning you the graph of the tensor R. To which graph? Understood? Right? Each tensor belongs to a graph. If you don't mention any graph details, everything will belong to the default graph. And if you want to mention the graph details, like what I'm doing, I'm creating a new graph, which is not the default graph here.
But R and S are both belong to the default graph.
As of now, both belongs to the default graph. Now, this is what I'm creating a new graph. Now, I want to create some information which is in this graph, not the default graph. We'll see now. Okay, if you do G dot, you can see, right, this is the new graph's address. It is different from the default graph. Okay, if you do this with G dot as default, A is equal to G dot. You can see this guy now belongs to default graph. Whereas if you do a graph earlier, it was that way. So you can see the execution can be parallelized because different graphs can be there at all. And one graph output can be input to another graph stream. Understood, right?
But literally that is minus how it is distributed.
You don't have to. All you have to write is, of course, you can create different graphs and all that. But if you are using high-level libraries like Keras and all, it will internally do things for you.
But if you have for two GPUs system, if you distribute, they will do it automatically. You will
you can. A lot of these things are abstracted if required. But frankly speaking, if you start working on this in a company and after some time you'll feel that the high-level ACIs are actually bane for you. Because you cannot go at a finer level and fine-tune things. To begin with, I will be abstracting a lot of these internal details, but as we start growing and as you start working on it, you'll see more and more low level you would like. Okay, because it gives you the control to change things at a very low level. Understood, right? What is graphs here? Yeah. Two different. So you just keep connecting, gathering this information. All this will become relevant very soon. Okay. Now we'll see so we understood graphs and of course. Okay, we'll come to that. collection only.
Get tensor only.
Okay, there are these APIs. We'll just let us get operation number. So you can, this is what you are doing. You are accessing this value A1. A1. So you have all those APIs. We'll see usage of them as we proceed further here. G clear collection will do. So this is for that particular graph, whatever operations you want to do. Okay, we will see. Let's see the fetches part.
Get collection by name is giving me
the tensor A, this particular thing. Okay, so if you do this right, suppose you have this and you do right, you can see here this is the tensor here A. Okay. Here it is returning an operation, and what is the type of it? A constant, because there is a constant here. Okay, we'll see view these things. Let me go systematically. I just jump a few things here. Okay, next is fetches actually. Okay, fetches means let's take a case. We had some. Suppose I have all this data. You can see here all the dependencies, right? Like A, B is there. DCD is multiplication of A, B, E is multiplication of B, C, and all this. Okay, so there are these values are new values. D, E, F. Okay, D, E, F. So now, if you want to get all the values, what will you do with dot? This is quite useful. Fetches D. You can see all the values that were corrected in intermediate state. You're getting that in one shot. Got it, right? You don't have to do session dot run CEV. You're executing DEF, all of them. Okay, this is known as fetches concept.
There's no need of that session then.
Huh? No. We need this session to execute this. Execution output is going to outputs here. Okay, like if you want to, like generally what you do to execute this entire graph, you call this session.run f, right? And if you want to get the intermediate values, which was on which f is dependent upon, you will have to execute again on them by session.run f, session.run e, session.run d. You don't have to do that anymore. Fine, right? Right. You don't have to do that anymore. Not only that, you can actually create tensor from NumPy. Okay. For example, if you have a NumPy data, import.
Can I assume that whatever you are showing me is actually something like linear regression?
No. Oh, this one. This is basic maths actually, not really linear regression. I'll come to linear regression. Then you have this import NumPy as NP. You create a NumPy data structure. Array. Okay. 1, 2, 3. Okay, this is the numpy. So what you can do is TF dot. Okay, you can see here it created a numpy tensor of 2 cross 3, but it does not have the value. To have the value, you can do session dot run. You have to do, right? Session dot run t. That's all you have to do. Then similarly, remember in numpy you have linspace to generate equivalent, right? You can do ef dot linspace start 1.0 stop. So 8.0. And how many data you want to generate? Generate 20 data. You want to see the tensor with TF session. Understood, right? This is the tensor. Okay, so you have all this sort of, I mean, you can generate random numbers, you can generate all this stuff with that.
What exactly has happened in this program?
So just using this linspace size, what it has done is starting from the data is starting from 1 and ending at 5. See, it's starting in 1 and ending at 5. Okay. When how many numbers it is trying to generate between 1 and 5 is 20.
Okay.
Okay, you can see there are 20 equally spaced numbers between 1 and 5. Very useful operation in data generation.
It's just random numbers. So if I run this program again, it will show different numbers.
No. This is fixed numbers.
Okay, fixed numbers.
Between 1 and 5, it is generating equally spaced numbers.
Okay.
But I think it always give the same number.
Same number. 1 and 5 equally spaced numbers. There is only one number. Fine, right?
Yeah.
Then in NumPy, you remember you have reshape, which adding one dimension you can do. Here also you can do that. Like for example, D is your one-dimensional array, right? Say you want to add one more dimension. So TF dot expand dims dimension D comma 1. Oh, sorry. Expand dims.
TF is a 2 dimension, 2 by 3.
Which one?
Here. Or 1 dimension.
One dimension. See, it became 20 cross 1. Understood, right? This is a very useful operation. Internally, whenever you're doing this vector operations, this is the one that happens. Right? Okay. Now, you want to do matrix multiplication. Okay. So you have this. What is the size? What is the shape for T? Is 2 cross 3, right?
Yeah.
So if I have 3 cross 1, I can do this, right? So very cold, right? There's some problem with this.
Yes, suggest me what should I read for linear algebra? Because I read in my one or 2 years back. I forgot like maximum of it. So someone suggests you go to Silverstein and D. So during very much I learned 7 or 8 chapters of Silverstein. It will take ages to finish it.
So quick thing, right? You can do this. The matrix operations and all that.
Matrix operations, I know. But if you go deep into deep learning, you may or may need all these SVGs.
Yeah, you need it. So what you can do is you can. What I do is I will precisely tell you this internally do by do x. If this is if you partial differentiation, right? I mean map propagation, right? If this is what happens because of this, I will tell the physical meaning of it. Okay, if you want to do the complete, and that best thing to do, but there is an infinite time in it. You continue doing whatever you're doing. Okay, and most of this stuff, I think basic stuff you already know. You'll find here some of these stuffs. What was it? ML class. Some of this stuff, what is required, you can check this out. And some basic things which is required for, I can tell you here. And
your basics,
yeah,
everything is given in one.
Basics only. Okay, then there is a Stanford notes on.
Silverstein. If you go to Stanford ML linear algebra, it will take you to Silverstein classes.
Yes. I think
the old way.
That's too vast actually. It's not possible for somebody. Here I think there was some those. It's video and all. I personally don't have. So try to do this. This is quite sufficient. This is the kind of summary of linear algebra, that cheat sheet of linear algebra. Okay, this is just 36 pages.
Okay.
Huh? Kind of enough that you need. And after all this, we need this gradient and all that. Okay, least squares. Pretty much fine. If you say, I mean, these are the things that I refer to. This universities has good thing, but don't fall for this Udemy courses. I find their content. I don't have a lot of reference, but their content is they miss the important part. And that's all actually. So these university courses, they are pretty much just that it is highly organized.
Very good.
But they have sufficient and good mathematical things. If you like it, then they can do it. Okay. So here in PRA, what I need is 3 cross 1, right? Three cross 1. Right, this is 3 cross 1. So T and D. So if you do EF dot Matmal. Right, it is giving you this. But of course, if you have to execute this,
What is Matmal?
Matrix multiplication. Okay, Matmal. Right, it is giving you this. Shape is 2 cross 1 as we expect. If you have to execute this, you just have to do session.run and inside that you have to pass this. Right, we learned how to expand dimension. You can of course do transpose of it. Understood, right? You have all the operations here. Right, you can see 2 cross 3 is now converted into 3 cross 2. This is just a summary of whatever is possible. Okay. More things are variables and placeholders. Okay. So let's take a 5 minutes break. Okay. Somehow I need to becoming so cold. It has direct impact on my throat.
You can feedbacks.
No, not like that. Actually, they told to bring laptop and I didn't eat food also, see a couple of things and not it later.
So you're working?
Yeah, I'm working. I'm working with How about you?
I'm marketing research.
Marketing research. Okay. So, obviously, this is going to be
It's not much useful. We are not started using deep learning and everything. My work is more of a research level work. For our things that we do regression and all a lot. Regression, decision, reason, that I am comfortable with. We do not use Python or R on that. I'm with R or SPSS we use.
okay.
So basic concept I know about veteran estimate. But really we are now at the front end. So now when we are 70 days, 8 days, we are also do and go. Like now where people do that. So the time facing. Just get out of this time facing role to that to this kind of role.
Yeah. Actually, I'm very much interested for this, especially this TensorFlow.
You already have this machine learning already.
Means yeah, I'm always started in a slow way.
Okay. So you've done a machine learning, basic machine learning.
Means like I'll tell you one thing. I am currently doing a project of developing a chatbot.
Okay, you do
in TensorFlow.
you're doing it. You doesn't know and see you have done a lot of that.
No, I'm still learning. It's a vast thing, right? It's not going to school. A lot of things are not clear. That's the reason I thought, okay, let me also start. Actually, I have done a lot of online courses.
Coursera.
The same TensorFlow, deep learning. Yeah. There are a lot of courses that are online.
Yeah, Udemy is there.
Many like data camp is there. Coursera is there.
Coursera, the entry network, entry one.
No, they keep giving ads actually, so I have done from data camp one.
So data camp, if you will do properly, theoretically, do the entry name one.
Sure.
Entry name, Coursera entry name. NG, the Chinese one, Chinese guy. These are the best.
What is the next site name?
Coursera.
Okay.
Coursera NG, do that. It's a good. Even I haven't done that. My friend has completed it. He's all praising for it.
Coursera, deep learning.
Deep learning, NLP. There's a one more called fast.ai, FAST.
Okay.
But that is for computer vision, mainly for computer vision.
Okay.
Fast.ai. Check these two things.
And then NGNI.
And NLP is a pioneer. He's one of the pioneer in deep learning.
Okay. So he's the person who will teach actually.
He's teaching. You know, have you done the machine learning course in person? The basic machine learning course. That guy used to teach the detailed decision algorithm.
Okay, see, I have done a lot of courses from Udemy actually.
You didn't even get the deep depth you won't get.
Oh,
They have to teach this guy only. This guy is very good. But if you have forgotten maths, then you are in trouble.
No problem, that will pick it up. But you know, the thing was,
Maths and stats,
to start from the basics now, that is, I found it good that Udemy actually.
Yeah, basic is good. Basic is very good. But if you want to get deep into it,
Go to Coursera.
And read books. Read books.
How much it will cost for this Coursera?
But if you have not done from the beginning, you do statistics, you know.
Yeah.
Then it's not a problem. Very more meanings.
And that means during my BTech and 10th class, this we did.
No, that's there. No, the likelihood ratio, chi-square, you know all this.
Yeah, I mean, I need to just brush up my skills on that.
So you still remember, huh? It's very good. I don't remember anything. Seriously, initially, I have done a course 2 years back in machine learning from this Hyderabad Institute, a 6 months course. Very good, very good. This faculty is excellent. They all pass out from MS, PhD from US in machine learning. Very good, expensive, 3.5 lakhs almost course. Every weekend, 9 to 6. So I used to go every weekend there. But I was trying to switch my job, but I was not getting good salary. Zero is giving me a freshers job, so I didn't take it. So let's see. And now I want to do some specialization for 4 or 5 months in deep learning, and then I'll get that one.
Yeah, see, actually, even I have been told, see, actually, I'm from a BBA background. I'm from a BBA background, you know, BA in big data. Also,
so I'll take 1 minute.
Oh, you need
Just go and have some tea.
Okay. Okay, guys. Oh, okay. We'll meet in 5 minutes. I'm just pausing the recording. Okay, so after this, we have variables and placeholders. Variables and placeholders. Okay, so as far as variables and placeholders is concerned, what's the difference, right? Take an example of linear regression. What you try to predict out there, you try to predict the coefficient and the intercept, right? Okay, so that means how you start, how you do that in TensorFlow is you start with some default, some random values. Okay, then you calculate the outcome. The A and B are random values initially. Okay. Based on particular value of X, you try to predict Y, right? Then you see the actual difference between the predicted Y and actual Y. When you see the difference between predicted Y and actual Y, then you come back and again fine tune the model parameters.
Is it similar to genetic algorithm? Because if you do genetic algorithm, you normally put numbers, draw lines, right? Then whatever the best line you choose, the best fit line.
Yeah, I mean somehow it's little relevant, not completely. Okay, because there are some other assumptions also. Okay, in case of, there are more details. I'll do linear regression. The reason why I'm saying this is the model parameters in A and B, right? that undergoes change every time. Okay, every time in the sense when you initially set them as random values, as the algorithm training happens, they undergo change.
This we're trying to understand. What you said, we have a data points and say for 2 dimensions in this space, we have numbers. And you randomly put few numbers in 2 dimensional space, and you try to find out the distance from the line from the.
No, not going there as of now.
Okay.
All I'm saying is, suppose you want to predict AX plus B. A and B, suppose you want to predict.
Okay.
You initially randomly assign it something, and based on gradient descent, don't worry about it now. You change it to fine tune it to get the correct A and B, right? Okay, so these value A and B undergoes change every time the training is happening. So these are known as variables because they keep changing. And X is your training data set, right? Okay, that means these are the data. These are the placeholder of data coming from outside. This does not change once the data has come to it. These are known as placeholders. These are like 2 different types of tensors. One is variables, one is placeholder. Variables means they can continue changing. They will change, they will update. Placeholders do not update, but they are offered from outside.
They are offered from outside.
They are filled from outside.
That's constant.
No. They don't change. Constant means you have fixed it during the coding itself.
AX plus B, B is the placeholder.
X is the placeholder. X is your training data, right? Okay, let me use it. It will be clear when we do linear regression. Okay, let me use it. Okay, for example, okay, you have this TF dot variable, right? Okay, so you can see this, it created a variable T, right? Earlier, what we have seen, session.run, see, it does not, I remember in constant this code executed. When we executed earlier the constant code, it executed. Here it didn't execute, and the error that will tell you trying to execute uninitialized variable, attempting to use uninitialized variable. Okay, because remember a variable needs initialization, so it will not initialize it. So we have given the value, but the initialization did not happen. To initialize this, you have to call this. Initialized all global variable. Now it is fine. Understood, right? So variables mean whenever you are using these variables, you have to initialize it globally.
Globally.
You have to initialize it. This load like T and whatever you have, right? T, S, U, V, whatever variables you have to initialize it. Then only you'll be able to use it. Okay, then okay, this is your variables. And what is the property of this T? You can modify it. We'll use it. Okay, we can modify it. Then see. Then let's see placeholder. Placeholders means this is the data that will be passing from outside. Okay, so for example, E1 of dear dot placeholder. Placeholder with default. Input is say 5 is the default value. Shape is 1 crossword. input with input shape. All it needs is generally takes tf dot. So this means it's a placeholder for 116 bits integer variable. That's it, placeholder. What is the beauty here is, okay, so if you do tf dot multiply p1 comma okay, you have this tf multiply, right? So let me put at z is equal to, remember we have not passed any value for p1. The beautiful part here is with tf dot session session as sys, right? tf session as sys. What we'll do here, sys dot run. Will it execute if I do like this?
It will initialize.
Hmm? Yeah, placeholder. This P1, what is the value of P1?
P1 is
nothing. It's just a placeholder now. It does not have any value. So what you have to do, many times what happens, this is what happens. You have coefficients and you need to give data from outside. This is placeholder. So you can find feed dictionary. What is right? This is the data which is coming. If you want, you can pass different data also. Like unlike hard coding, where will be hard coding? Here you can have a list and you can pass for all the elements of the list, right? Right, you can put this in a loop, isn't it? Is it clear what is placeholder, what is variable? Variable, though variable I'm not doing anything here now, but variable actually can undergo change. You can modify the variable. Placeholder you cannot modify as you run, but this is getting data from outside. Okay, by feed dictionary, variable you'll see me changing it. Okay.
Could you give me some practical example of placeholder? Because
I know.
I'm
not very clear.
Shaky.
No. So after this, we are doing linear regression. Okay. So that where we'll be using this placeholder and variable. Okay, and it will actually fall in place. Okay, so let's generate some fake data. Okay, and
don't we have any built-in databases in Python that we are generally having
built-in
databases?
Like libraries?
Libraries.
Yeah, I mean, here it has, I mean, you have some library for linear regression and all that. See that. Okay. But here I wanted to show it little inside out. Because otherwise you'll never come to know the difference between placeholder and this guy. Okay. Okay, so let's import it. Import tensor as TF. Okay, let's generate some data. Okay, let's do simulation. Import numpy as NP. Sample 10,000 x equal to NP dot line space. This is your x, this is your y. Understood, right? No noise, I mean, nothing much. Plain, simple x and y are there. Okay. Now, this is my data. So what you have to, what is intercept, what is slope? 2 is your slope and 10 is your intercept. This is what you have to predict. Will not tell anything to the model, but we will predict. This is the validation thing that I do with machine learning also. Validation thing that we'll doing it here. Okay. Now, what you have to predict? You have to predict in a model A and AX plus B, right? A and B you have to predict. X is this and Y we know Y is this. Okay. So now, so your A and B, as we discussed earlier, it should be it will undergo changes. That is why A and B should be variables. A is equal to variable. Okay, and it should be initialized with some random values. Here, I'll make it random values, right? So 0.5 as a could be any random value. Just here. My hard-coded random values. So now, and we need placeholder. What will be the value data in the placeholder? Okay, what will be the value for placeholder? Placeholder will be X and Y. Right? X is X data. Another data. Tier not. Data tier dot variable is here placeholder. Right. And what is the shape of it?
Shape,
shape, this placeholder, it will be generally if you have the data, rows of column. When you're treating in the machine learning, the data will be in the column, right? Right, 2-dimensional stuff it should be. We have to convert the data into 2-dimensional. Okay, so shape if you do, it should be none comma 1. None means you don't know how many rows of data will be there. 1 because 1 column. right? None comma 1. And what is the data type here? TF dot float. What's the data? TF dot. Okay, output also you are keeping in the same dimension. Okay, now you have the model. What is the model? AX plus B. Okay, so TF dot and TF dot multiply. What is the shape of A?
A
1 cross 1, right? Okay, the shape of A is 1 cross 1. So actually, we have to make it 1 cross 1.
comma 0.5.
Huh?
None comma 0.5.
So,
what is one comma, right? It's only one single dimension, right?
if you have to represent something 1 cross 1, it will be like this, right? This is 1 comma
1 comma.
1. You can check that, no problem. So, one comma 1. Right. So this is 1 comma 1 and this is also 1 comma 1. So TF multi, because we need to have the same stuff, right? AX plus B, 1 comma 1, and you have data. So you have to do the reverse, right? Data, because
row
in A and add B to that. Fine. So input Y of add. Oh, somewhere I made in 32. Oh yeah. Understood, right? This type should be same.
Line 12 I haven't understood.
Which one?
Line 12.
So this is AX plus B. Remember, it's a very low level code. So we have done the reverse so that the column of this guy is equal to height of this guy. That's why. So this is the model AX plus B. Okay. Now, okay, what you have to do, you have to fine tune the model, isn't it? Right. So remember, you what you have to do, you have to. How does this entire thing proceed? This entire thing proceeds first. You randomly initialize model parameters. Based on that, model output will give you some output. You compare this output with the actual output. Based on the value, you fine tune the model parameters. This is the entire process that runs. Okay, this is the entire. This is the mechanism by which the entire learning happens. Okay, so now. So this difference between actual data and the predicted actual outcome and the predicted outcome is called loss. Okay, and we use gradient descent, which gradient descent will use this loss to modify model parameters. Got it, right? Gradient descent will use loss to modify model parameters. Okay, so the next thing is we should calculate loss. Yeah. So what is loss? Loss is basically sigma 1 by n of sigma of sum of all difference between actual value and the predicted value.
Loss is not loss residual, right?
Huh?
It's nothing but residual.
Residue, right. L2 method we are using where we can use many type of linear regression. We are using B square linear regression. Right, what it is doing, actual value and predicted value is finding the difference, squaring it up, summing it for all the data, then finding mean of it. Okay, so that is what we do. You have directly some API to do that. Reduce sum. reduce sum. Okay, then TF dot power. Difference between actual value and this guy, right? So model minus target. These two guys, power model minus target, comma 2, right?
What is the reduce sum function?
Reduce sum, it will actually sum them all.
Sum.
Reduce sum means you have two vector, right? You have to find the difference between two vectors and do a square of it, and you're summing it off.
Okay.
Right? And remember, if you remember, you have to divide this with
TFO UW is
power.
power.
Okay, it will find the difference, which is the predicted value, this is the target value. It will square it up. Okay, that is what power is doing here. And this entire thing you have to divide it by 1 by, I mean, it will be the I mean, if you remember this maths here. It's 1 by 2m actually. Loss, yeah, you see this loss function?
Yeah,
it is 1 by 2m.
I see, don't know why they do 1 by 2m.
No, actually, this is equivalent to square root of this. That is the basic combination maths, is square root. 1 by 2m is equivalent to the square root of this. Okay, equivalent. I mean, it's not equal, but you know, this one thing we're not invented today. This one, 40 years back. A lot of things work with this assumption, and they work well. So they still continued using it. Okay, that's the history. Okay, because that time doing square root was not easy thing. Okay. So 1 by 2 is equivalent to that on larger scale, and there is some error thing which gets nullified. So there it is. 2 into samples. This is a loss function, right? What you have to do is to minimize the loss. And who will do this? Gradient descent optimizer will do this. Okay. So what is gradient descent? Gradient descent will use this loss and modify model parameters, right? And gradient descent, if you remember, it needs one parameter, learning rate, right? Gradient descent, what is learning rate? It is the jump size, right? Jump size to which it will work. Okay, so yeah, so jump size, gradient, like I'll show it here. Like here it is, right? So this is the stuff, this is the data. You have to jump from here to here. That is decided by your gradient descent actually.
But the jump size also keep reducing, right?
The jump size does not reduce, it is fixed. But jump size can be controlled by another parameter m, or which I will not talk now, later on I'll talk about. Okay. But as of now, we want to use gradient descent, which will be controlled by what you're saying, right? The jump size reduced, it is there. It is there in in your neural networks, right? Vanishing gradient descent. So what it does is it starts with whatever we configure. Jump size is one parameter. There is another parameter which initially it will jump bigger, but when it comes to the closer, it will reduce the jump size. That is also one parameter but we don't configure it as of now. But in neural network, that is configured by default. I'll talk about it when we get there. Okay. So we have this 2 into samples. Okay. Loss. Then we have learning rate. And TF train dot gradient descent optimizer. It takes only one parameter, learning rate. This is optimizer. There are a lot of other varieties. This is gradient descent, which we have seen it using in our linear regression. Okay, if you're not comfortable with this, please go through this earlier information, or let me know tomorrow. Okay, if you find any difficulty. Okay, this is your optimizer. So what you have to do now is you have to minimize. Using this optimizer, you have to minimize the loss. OPT dot minimize loss. Okay, so if you see, this is the heart, this is the thing on which the entire graph is dependent, isn't it? Okay, this is the train process. So what will we do with what will we now? With if session says dot global variables initializer. We initialize A and B. This is required because those are variables, right? Then you do session dot run, and remember, okay, remember that we have to pass. I mean, we will do that eventually, but what we'll need to do here, we might to pass the data. I mean, subset of the data every time. Among this 10,000, we won't pass 10,000 data in one shot. So here we'll actually pass subset of the data.
But yeah, that's really
10,000.
No, it's called 10,000. 10,000.
Oh, 10,000. Okay. So what will you do? We'll just batch it up. So let's configure something. What is the point? See, one possibility here, you take one x and one y, run the entire graph, find the loss and modify the model parameters. This is very slow, very slow compared to you give some batch of data, like 20%, 50% of the data randomly selected. Okay, run the entire graph, compute the loss, and based on that modify the model parameters. Understood, right? You can of course do that here, that one data at a time. Okay, but the convergence is very slow. That is why you pass subset of the data. Like among this 10,000 data, maybe I'll pass 1,000 data. Okay, so that my convergence is faster. Okay, it will take randomly select 1,000 data from my data set.
Here, where is the convergence is coming?
I haven't written the code. Okay, convergence means, you see what is convergence here? You pass some x and some y, it will find the loss and it will modify the model parameters. How fast you are modifying the model parameters really defines how good your model will converge.
But ultimately, when the error would be minimum, that is the convergence, right?
When the error is, that is the final outcome desired. What is convergence? How quickly you are getting to there. There are, I mean, if a model is there which is conversing very slow, it is as good as not good model. Because if it's taking a lot of time, it doesn't make sense. Right? So you have to do the changes. I mean, that is what your batches does. Batch means you will pass subset of the data. It will quickly reduce the error. How quickly it is reducing the error is what is convergence. And the objective is to definitely minimize the error as much as possible.
Let's try to find out why, say we have segment the data in three different segments, 300, 300, and that's 400, and putting the data in batches. That means what you are saying, right? So how initially when you get the data, you will go by each point, the 1 point at a time, right?
What will you do? You will, I mean, when suppose you have, like in this case, if I configure batch size is equal to 100. Okay, that means among the total data, it will take 100 data from there. Okay. After taking 100 data from there, it will compute loss for this 100 data. What is loss for this 100 data? Sum of that loss function will be there. Using this outcome, it will modify the model parameters. This is one case versus one data compute loss, modify the model parameters. This one data compute loss, modify parameters is very slow. That is why you do the training by batches. Okay, so that is why in neural networks and deep learning and everywhere you will see batches being used. Okay, because you get more generalized loss. Batch size is 100. Okay, so now I want to run it for say 100 times. For I in right 100 times I want to run this 100 batches. I will pass this. Every batches I will see the.
Whereas you will from 1,000 samples, you will take
10,000 samples. I'll take 1,000 samples maybe. From 10,000 samples, I'm taking 1,000 samples and I will run it 100 times. Okay, maybe.
If you draw 100 sample size, 1,000 sample size each, every time you have.
Every time, yeah. Randomly it will select.
And 100 times you will do that.
100 times I'll do that.
And you will take an average error from there.
Each time it runs it, okay, it will compute some error, some loss. Based on that, the gradient descent will modify. What is the purpose of gradient descent? Based on the loss, it will modify the model parameters. That is A and B.
You will get 100 different.
No. Yeah, I got your point. So once you, first time when you do it, that is by variables, it will modify A and B. Next time when you're doing it, you're working on the modified A and B. Got it, right? That is because those are variables and they can, I mean, they will change, and that's the purpose. Okay, rand index. Some random index I'm taking out of this 1000, and there is a function, this random choice. Okay. Okay, it will give you random indexes randomly. Then you have x_t. Let x and y is here, right? x_t, x rand index. This is very important code. X y_t. If you understood this, you understood half the neural network actually. Y. Right? Right. Part of it I'm taking. Then you do session.run. Then you do the session.run and you're passing here.
What I in rand.index, one variable.
So what is rand.index? Between 1 and 10,000, it will be 1,000 numbers.
It will give you some
1,000 numbers, right?
1,000 numbers it will give you. And at your x_t, x equal to x is some array number, right?
X is the data that we generated.
The random number from x line space is that we have generated that number.
Right.
So it will give you that 1,000 numbers, but it will give you only one. So okay, fine. So that every time you give you.
Yeah.
Okay. Got it.
Okay. Then session.run train, and what is the data that you have to pass? We have to pass it using feed dictionary.
I will just ask what question after you finish.
Feed. Okay, see here, this train data, this is a train data, right? Okay, this train and loss is the loss takes two information. Model is here. So you can see here it takes data and target, that is your thing, right? So pass here data x_t. Reshape, right? You need one as one column, right?
-1 what?
Number of rows is typically derived, one column. Data x cube is one column, right?
Yeah.
-1 means you get the number of rows that is required. Okay. So target. y_t. Reshape. Okay, so you have this. This will run every time, and it will return you what is train the loss. Okay. Now what we want to see the loss function, isn't it? And we should also see this after every time what is the value of A and B, right?
Yeah. How it is improvements, how it is. There's one outline here. But every X has a Y. Right? But here, what may happen is that X, because if you take rows and columns, for every X there will be Y. But if we take every time we are changing in numbers, but the X would change and Y would be different.
No. Both of them are same index, right? So for a corresponding X, corresponding. So that's what I'm saying. This part is very important here. Each line of it. Okay. Session dot. Mostly, I mean, it's easy only. Is that okay? It should be okay. And at each stage here, you have A and B, right? Right. Okay, the first one is loss. You see here. First loss was 11. Second loss was 6. Third loss was 4. Similarly, you can see going forward at 100 iteration, loss is reducing. And okay, this is your A and this is your B, right? A it is coming 2.2, B is at 8. Okay, if you do it further, it will further reduce. Okay, this is just with 100 iterations.
There is no ultimate.
We didn't write that threshold key, the also is the stop and all that. The very low level code, and this is very important code. I know that today it's a little overwhelming the first sessions getting here, but I can't help it because the course is a little restricted. Okay, so please be with me. Okay. And especially it's difficult when you're attending online also. Okay, so I'll upload this code in GitHub repository.
Yeah, I will just GitHub and you just give me the address of this.
I'll do that. Right, so it will further converge. You can see it is reducing the first one, 2.29, 2.299. You can actually increase the gradient descent also. Maybe whatever value we had, okay, it can converge first. So you can play around. You just change the gradient descent, see it is increasing, coming faster.
But gradient descent does not talk about the loss that we are getting.
What is gradient descent basically, right?
Derivative.
Actually, right. But what is the physical meaning of it? You plot the loss graph. It just finds the way to reach the lowest possible loss. That's what. I mean, it uses loss information to find the base of it. Okay, in simple words. Okay. Go through this.
We will always give you not guarantees.
It's not right. It is not a guarantee that you will get the local minima with that.
Universal minima.
Global, sorry, it will get the global minima with that.
So that means should we initialize the gradient descent, the running rate? No, gradient descent we have initialized once, right? Should we initialize for 4-5 points at least in the code?
3 files we had, right? I'll just name it. Yeah. One part. So that just 1 second, let me upload it because there are a lot of files. TF3.